Hello and welcome to this video about SolidThinking Compose. In this video we will take a look at how to just use some basic matrix calculations in Compose. Let's get started. I have prepared two matrices. The first one is 1, 2, 3, 4, the second one is 5, 6, 7, 8. Simple matrices. I want to add those two together. For example, C equals A plus B. You can see it's element-wise added. So 1 plus 5, 2 plus 6, and so on. You can also subtract it. For example, C equals A minus B. You see that the difference is always minus 4 between those matrices. The next thing I can do is matrix multiplication. So C equals A times B will be the matrix product of A and B. As you surely remember from calculus, you just use the row vector of the first matrix and multiply it with the second, with the column vector of the second matrix. So in this case it would be 1 times 5 plus 2 times 7 equals 19, and so on. You can also divide. C equals A divided by B, and here there's two different ways to divide. This would be called the right hand side matrix division. So it is the same as C equals A times the inverted form of B. You can see that's the same. There's also a left hand side divide function for the matrix. So you can also say C equals, now you have to use the backslash, A backslash B. And this would be the same as saying C equals the inverted form of A times B. And it's a simple way of getting a solution. If you have an equation of AX times B, you just simply say A left side divide A backslash B in this case. Yeah. All right. Now let's see. You can also do that element-wise. So multiplication, you do not have to use the matrix multiplication, but you can also specify an element-wise multiplication. So just remember, we have A and B, and we want to have element-wise multiplication. We just say A dot times B. Now you can see 1 times 5 is 5, 2 times 6 is 12, and so on. You can also divide with this manner. Let's see. We have, for example, a sequence of numbers 1 to 10, and we want to have the powers of 2 for 1 to 10. So we can just say U equals 2 dot power V. So element-wise, the power of 2 is calculated and put into this vector U in this case. You can also concat matrices together. So for example, if I want to concat A and B, I can do that vertically or horizontal. So for example, in this case, maybe we will just do C equals brackets A comma B. This is the first way of concating them. If you want to, you can do that also with horizontal cat. A comma B, it's the same thing. And vertical, word cat, oh, that was too fast. Word cat, A comma B, give you the vertical result. And now you can also insert or change values within the matrix. So if you have, for example, your C matrix, and you want to say the third column in the first row, this 5 should be 0, can say C first row third column equals 0. Now you can see it changed from 5 to 0. You can also just put some whole columns or some whole rows or change them. You can do that by specifying C. You want maybe the second row, and you want the first two values, first two columns, specifying by 1 column 2. equals 10, for example. So second row, first to the second column equals 10. So those two values would be 10. And here you go. You can also delete columns or lines or certain values. You can say, for example, C. I want to delete the third column, for example. All rows, comma, the third column equals just the brackets, meaning there's nothing in there, empty, and it gets deleted. The last thing I want to talk about how you can concat a vector in between a matrix on a certain position. For example, if I have a vector f equals 1 and 2 column vector, and I want this column vector to be put in the second position of C, right here, can do that with just the horizontal cat function, d equals horizontal cat. Now I have to specify for the first column of C, all rows, first column, comma, now I have the vector f, and now I have this the left the rows, the columns left in C. So C, all rows, comma, and in this case 2 to 3. So again, it's C, all rows of the first column, then F, and then it's the columns 2 and 3 from C. Now you can see this was C matrix, and this 1, 2 will get put into here, so it's here, and this is the rest of C. So I hope you enjoyed that video. Please leave a thumbs up or subscribe on this channel, and I will be happy to see you in the next video. Thanks for watching.